So when somebody says it changes a tenth of a degree, or when Gutierrez says if it changes a half degree, we're finished as a species. This is an existential threat. People have to ask, what the hell are they talking about? I have my thoughts as to why it is that educated people don't ask questions. For most of my career, I've been a teacher. And you have some students who are really very good, but most are okay. They're not great. They're going to have jobs, they're going to do them reasonably well and so on. But for them, succeeding in school is mostly pleasing the professor. So no matter how stupid the professor might be, they've learned to rationalize what the professor said. And so the skill that most people pick up at the university, I suspect, is the ability to rationalize any statement, no matter how ridiculous. So if somebody says a half degree is the end of the world, I can see that. I don't argue that there can't be warming, but this is not an existential threat. Steve Koonin writes a book. He is looking at the UN reports. In the reports, you have many different sections. Only one deals with science. That scientific report never says that it's a big deal. It simply says, we're more likely to warm than to cool, and it'll be a few degrees, maybe. But nobody in those scientific reports is saying there's going to be extreme weather, or it's going to be flooding, or the world is going to end. No, that's politicians. And the politicians have arranged the UN reports so that you do have one section on science, and then you have lots of other sections that are not on science that say crazy things. And so you say the UN says this, but it doesn't say it in the science section. They designed it so that they would have a platform for issuing crazy statements, but there would be one section that is the science that no one would read, but allows them to say they had hundreds of scientists working on this.
Some decades ago, you were one of the lead authors.
Yeah, I was working with the IPCC. And, it was absurd. In order to write 3 or 4 pages with 2 other people, we traveled around the earth 2-3 times. There was a meeting in New Zealand, a meeting in Nairobi, a reading. And, the 3 of us, there was a fellow called Pierre Humbert, who's today at Oxford. There was another guy from France. And we all decided, look, we may not agree, but let's not say anything that we know is false. And so the section was on what we knew about feedbacks. And it was a completely honest section. It was biased. We were told we couldn't attack models too much. But basically what we wrote was honest. It said we didn't know what we were doing.
So models?
Models are their own story. Models are useful, but not for prediction. The reason they're not good for prediction is we don't know the feedbacks, we don't know this, we don't know that, we don't know clouds, we don't resolve this. So they cannot handle processes that are essential. They're useful if you're doing theory. You can look at the models and see how things interacted, and then focus on those more carefully to see whether you understand the interaction. So there is a kind of back and forth between models and theory and so on, but that isn't how they're used. The issue began with no science at all. It began, as I said, with global cooling. As long as there was some way this crazy number was showing cooling since from about 1939 to 1973, they said, well, let's say it's cooling. And you then had models, they were called the Budico-Sellers models. All of us liked to play with them, they were cute. They showed if you reflected light with sulfates enough, the original version of the model would give you an ice-covered Earth. That seemed very dramatic. And then people, including us, began showing, well, if you put in something more realistic in the tropics, it stopped there at 30 degrees. And then finally, in my course notes, I have a problem where you put into this model the change of seasons, and the model falls apart completely. So for the global cooling, you had the model you needed to give a scare story for cooling. But then in '73, in the 70s, it stopped cooling. So you needed something else. What was the next thing that came up? It was, again, the energy sector. Acid rain. The forest in Germany was dying. Unfortunately, after a few years, the forest stopped dying. And so acid rain was not too useful. People tested it. They found it didn't have much impact. But then they noticed the temperature was increasing, and that they liked. Why did they like it? Because the reason you would give for the temperature increasing is CO2 was increasing. Why did you like CO2? Well, with global cooling, you were worried about sulfate aerosols. The trouble with sulfate aerosols is we know how to clean them. We can build a coal plant that has no sulfate emissions. Well, what good is that? CO2, nothing can stop that. It is the product of any burning, including breathing. So you generate a lot of CO2. Anything that burns a fossil fuel produces CO2. After you clean every real pollutant out, you still have CO2. So this was guaranteed to get rid of any fossil fuel. And that was its attraction. And that's what we've gone with for the last, since 88. In 1988, you had a Senate hearing in the US, and you had a man called James Hansen testifying. It was an interesting issue. It had been going on for some years already, but he came there and said that increasing CO2 was going to cause a lot of warming. And Newsweek, it had a cover showing the Earth on fire, and it had a label, "All scientists agree." And that was very interesting, because at that time, almost no scientists were working on this. People were told all scientists agree. Now, think of that from a propaganda point of view. You don't know science, you haven't studied it, most people haven't studied it. Even among the people who study the science, you are told all scientists agree. This is a source of comfort. You don't have to understand it. All scientists agree, you can agree too.
Actually, we hear it more and more nowadays that there
But
is
now you have more and more scientists.
97% consensus.
Oh, that's fake. So, for instance, if you asked the question, is doubling CO2 more likely to warm than to cool the Earth? I would think you'd get 100% agreement. But that's not the same as saying it's a serious problem. So at that level, if you ask the right question and put a funny interpretation on the answer, you can say all scientists agree. You just haven't said what they agree with. Whenever you hear consensus science, you know something is wrong. So, for instance, this was in the Soviet Union with Lysenko. Yes, there was a consensus in favor of his view of evolution, because if you disagreed, you went to the gulag. I mean, it's a powerful argument. I mean, today it's equally true if you're teaching and you're not part of the consensus, you don't get paid. It's better than the gulag, but I mean, it's when you have very little CO2, each molecule is pretty effective. But we have so much CO2 in the atmosphere, even though it sounds like not much. We have so much already that when you add a molecule, it doesn't do much. The way this shows up, and this has been known since a man called Arrhenius, a Swede around 1900. The way it shows up is you get the same effect of CO2 every time you double CO2. So for instance, if you start out at 280 parts per million, and you go to 560, doubling it, you get about a half degree. Now to get another half degree, you have to double 560 to 1120 to get the same half degree. So now you needed, instead of 280, you needed 500 some odd. And then to get another half degree, you'd have to add 1,000. So, it's saying each molecule does less than its previous one. And that's been known, as I say, for more than a century. But, think about it with CO2. Let me ask a simple question, because I don't think people even understand. I mean, what happens if I get rid of about 65% of the CO2 in the atmosphere? Do you have any idea?
No, I don't. I have a suspicion. I suspect that it is not going to be very good for nature.
But forget for nature. How about us?
Exactly, because we're part of nature.
We'll die. We'll die of starvation.
Put simply, yes.
At 160 parts per million, virtually no plant will survive. No plant survives, there's no food. And I think they're realizing, people are saying, you draw it like this, but this is 1 degree. That's not much. And they're worried. This is not getting people worried enough. So they're saying, well, showing them a flood, showing them a storm, that is visually convincing. You could get 5 or 6 pictures each month of some place on the earth where something dramatic has happened. And you can say this is a 1 in 100-year event. And people don't figure out a 1 in 100-year event. Someplace on earth is occurring every month, or 5 places every month. You have a picture of that. You now put that on television, and you can associate, quote, climate change with something dramatic, and people see something dramatic, and so this helps them to visualize some terrible future. Gore predicted New York underwater by 2000. We should notice it's still above water. All these predictions always fail. At some point, you have to say, if all the predictions fail, maybe your ideas are wrong. I mean, it's...